Hey everyone, welcome back to another video. This one is going to extend from the last video and it's going to be on prime factorization and the least common multiple. So we're going to be looking at composite numbers and then finding prime numbers that are factors of those using a couple of different methods. So prime factorization in essence is just the product of prime number factors that end up equaling that number. And so importantly, it's probably good to just kind of get a feel of what prime numbers we'll probably use. We won't go anywhere near up to 50, but it's important to note this list of prime numbers that are less than 50. So we've got 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. And so just to remember that what prime numbers actually are numbers that can only be found using itself multiplied by 1. So composite numbers have itself multiplied by 1 as one way of expressing it, or we could use 2 times something or 3 times something. Some other way of using factors that doesn't involve itself and the number 1. So the method that we're going to look at here is called the factor tree method. So I'd recommend writing down the steps on the left-hand side here. But in essence, what we're going to be doing is we're going to be finding any factor pair of the given number and using these numbers to create 2 branches. So it doesn't matter what it is. You can see on the right side in that factor tree, we've got 36, and we know that it can be broken up into 3 and 12. At this point, we can look at those 2 numbers and determine if these are prime or composite numbers. You can see on the right-hand side that 3 is actually a prime number, so we can circle it because it can't go any further. The only factors of it are 1 and 3. 12, however, could be made up using 12 and 1, 2 and 6, or 3 and 4. So we can use any of these factors to make up the next branch of the factor tree. In this example, we've picked 3 and 4. We repeat the process and we say, okay, is 3 prime? Yes, it is. Is 4 prime? No, it's not. How else can we make up 4? So we know we've got 2 and 2, and then finally we evaluate whether those are prime numbers, and 2 is a prime number, therefore we circle them. And then ultimately we can say that if we multiply 3 by 2 by 2 by 3, we actually make up 36. And so just to check that using some mental math, 3 times 2 is 6, times 2 is 12, times 3 is 36. So onto an example here. So to start off, we want to write 48 up the top of our factor tree. Now, how can we make up 48? I'm going to go with 4 and 12. So 4 times 12 does equal 48. Now we look, is 4 a prime number? No, it's not. So how else could we make up 4? We could say 2 and 2. Now you're welcome to work your way down one branch and then go to the other branch if you prefer. That's the method I like to use. Otherwise, you can work one step at a time. So you could go to 4, check if that's prime. No, leave it. 12, check if that's prime, and then do the same process and then go to the next couple of branches. Or you can just work your way down one side and then go back and do the other side. So here I can say 4 is made up of 2 and 2. 2 is a prime number, and so I can circle both of those numbers because we know the tree ends there. Now 12, how can we make that up? We have 3 and 4. Now 3 is a prime number. 4, however, we determined before is not a prime number. If you want to learn how to determine whether the number is prime or composite, go back and check the last video. I believe it was 2.4, and you'll get some tips there. So 4 can be made up of 2 and 2. And finally, we know that 2 and 2 are prime numbers. And so what we could say here is we could say 2 times 2 times 3 times 2 times 2 is equal to 48. If you want to mentally check that, 2 times 2 is 4, times 3 is 12, times 2 is 24, times 2 is 48. Another way we could write this, if you remember from a couple of videos ago, we can say if we've got 2 times 2 times 3, times 2 times 2. We've got 4 2's there. And remember, we can use exponential form for that. So we could have 2 and then to the power of however many 2's we have. And so we have 4 2's. So 2 to the power of 4 will be 2 times 2, which is 4, times 2 is 8, times 2 is 16. And then we would multiply that by 3 to get 48. And so that also equals 48. So 2 different ways of expressing the same thing there. Same thing here, slightly larger number. So we want to write 84 up the top. Now, how else can we express 84? Well, to make it easy, we could do 2. And so if we divide 84 by 2, we would get 42. Now, if you remember, 2 is a prime number, so we can circle that. So now we just have to work on this right side. And so 42 can be broken up into 21 and 2. So I like to just divide by 2 to make nice and easy for me. So we can circle that too. Now 21 can be made up by 7 and 3. And so 7 is a prime number and 3 is a prime number also. And so what we get here is 2 times 7 times 3 times 2. Or alternatively, we can get those 2's grouped together as 2 to the power of 2, or 2 squared, times 7 times 3. And so just mentally, to make sure we've gotten this correct, 2 times 7 is 14, times 3 is 42, times 2 is 84. And so that is correct. Another way we can find prime factorization is using a method called the ladder method. And so when we're using the ladder method, you can see a little bit of an image on the right-hand side. So what we want to do is we want to divide the number by the smallest prime. Then we want to continue dividing by that prime until it no longer divides evenly. Then we divide by the next prime until it no longer divides evenly also. Continue until the quotient is a prime, and then write the composite number as the product of all the primes on top of the ladder. And so you can see in this example here, we've got 36, which can be made by 2 times 2 times 3 times 3. And so we've worked our way up that ladder. So we've started at 36, we've divided by 2. Then we get 18, so here. And then we can also divide that by 2. We can't divide 9 by 2, so then we look at the next prime number. So we can divide 9 by 3, which gives us 3, which is a prime number. And so these 4 numbers would then be our prime factors. I personally prefer the factor tree method, but you can pick and choose which one you like. Obviously, just practice both and see which one resonates with you. So find the prime factorization of 120 using the ladder method. So the first thing here is we write 120. We write our little, that looks more like a square root. I might just go like that. So 120, now we want to use 2. That's the smallest prime number that we can use. Remember, we can't use 1. So 120 divided by 2 will then be 60, which we can continue then to divide by 2. So 60 divided by 2 will then become 30. 30 we can divide by 2 again. We would then get 15. Now, here we can't divide 15 by 2. It is not divisible by 2, but it is divisible by the next prime number, which would be 3. So we can put 15 divided by 3 and we will get 5. Now, at the top of the ladder there, we have 5, and 5 is actually a prime number. So here we can circle the prime numbers that we have. So we've got 5, 3, 2, 2, and 2. And so you can write this as 2 times 2 times 2 times 3 times 5. Or we could group these 2's together and have 2 to the power of 3, or 2 cubed, times 3 times 5. And so just to quickly check, 2 times 2 is 4, times 2 is 8, times 3 is 24, times 5 is 120. And so we have got that correctly. So that's the ladder method. We'll do another example of that. So using 48 this time. So remember, we just start with our smallest prime number, which is 2. We can divide 48 by 2 to get 24. We can then divide 24 by 2 to get 12, which we can divide by 2 to get 6, which we can then divide by 2 to get 3. Now 3 is a prime number, so therefore these are our prime factors of 48, sorry. So we could say 2 times 2 times 2 times 2 times 3 is equal to 48. And so remember, we can group these together as 2 to the power of 4 times 3, and that will also equal 48. So just to check there, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. So we have got that correct. All right, so now we're looking at the least common multiple. And so this can be abbreviated as the LCM. But effectively what we want to do is we want to find factors of a number. And then if we have two numbers, as an example, we could have 10 and 25. We could then find multiples of that number. So of 10, we would do 10. And then the next thing would be 2 times 10, 3 times 10, 4 times 10. And so we'd get 10, 20, 30, 40. Whereas 25, we would go 1 times 25, 2 times 25, 3 times 25, 4 times 25. And then we would just find some crossover. So we would circle the common numbers that are in both of these lists. And so what we would then get would be a least common multiple, which is the smallest number that we say circle that is common in both lists, and that would be the LCM, or the least common multiple. So what are the steps that we would need to take? And I recommend writing these down for your first couple of ones so you can reference. So we first want to list the first several multiples of each number. Then we want to look for multiples common to both lists. If there are no common multiples in the list, we then continue to write out additional multiples for each number. Then we look for the smallest number that is common in both lists. This number will be the LCM. So we've got 15 and 20. So remember, all we're doing is we want to write out 15, and then we put 20 somewhere below it, and we just start saying 1 times 15, which is 15. 2 times 15, which is 30. 3 times 15, which is 45. 4 times 15, which is 60. And maybe we'll go to 10. So then just keep increasing this number by 15. And so I won't keep saying it, but this is 5, and then 6 would be 90. Then we get 105. Then we get 120. How many is that? So 2, 4, 6, 8. So 2 more. Then we get 135, and then 150. And so for 20, we do the exact same thing. So 1 times 20 is 20. 2 times 20 is 40. 3 times 20 is 60. And this pattern will continue on until we get to 10 times 20. So we get 80, 100, 120, 140, 160, 180, and 200. Now we will go through and we'll circle the numbers that are common in both lists. So I can see we have 120 and 120. So those are common. Do we have any smaller ones? Well, I can see we've got 60 and 60 there. And I believe that's it. So which number is smaller, 60 or 120? Well, 60 is, therefore the least common multiple is 60. So then we can also use prime factors to find the LCM of two numbers. So the steps here would be to find the prime factorization of each number using whatever method you want. So either the ladder method, or we can use the factor tree method. Then we want to write each number as a product of primes, matching primes vertically when possible. As an example, if we've got 2 here, we want 2 there. Then we want to bring down the primes in each column and then multiply the factors to get the LCM. So you can see here if 12, we've got 2 times 2 times 3. And so we've matched these and we just bring this down and we will get our LCM. And so remember, we have to put each one down. They should be matched. So one of each. So an example here using 15 and 18. So we'll use the factor tree method for 15. So we have 15, which can be made up by 3 and 5. Now 3 is a prime number, so we can circle that, and 5 is also a prime number. And so 15 could be made up by 3 times 5, which equals 15. Now I'll write over on the right hand side, we'll use the ladder method for 18. So 18 we can divide by 2. That gives us 9. 9 we can't divide by 2, so therefore we have to move to the next prime number, which would be 3. This 9 divided by 3 would be 3, and these would all be our prime numbers. And so now listing them in terms of our columns, we could line them up and say 2 times 3 times 3 equals 18. And now we can find our multiple. So we can put a line underneath and we could say we bring this 2 down, gives us 2. The 3s we have in common, so we bring a 3 down. This 3 we don't have in common, but we would need to bring that down. And then this 5, also not in common, but we just bring that down. And so what we get is the least common multiple should be made up by 2 times 3 times 3 times 5. And so that would be 2 times 3, which is 6, times 3 is 18, times 5 is 90. So at this point, we can see that we've found the least common multiple using our prime factorization. So we haven't need to list out those numbers and then do our multiples by hand. This is another way we can approach that. It's totally up to you. This one can be more work. It depends whether you have to find prime factorization and then you want to go find the LCM. You can do that. If you only need to find the LCM, maybe to be easier for you just to list multiples, you would have only had to go 5 deep for 18, so 5 times 18, or 6 times 15, so that's not too bad. But obviously larger numbers there would be easier with this method, so just play around, see which one you prefer, and just get used to using all of them where you can. So we'll have another go at that one, because that's probably the hardest thing we've learnt today. So we want to find our prime factors of 50 and 100. So I'll use factor trees for both here. But 50 divided by, we can find 2 and 25. 2 is a prime number. 25 could be broken down into 5 times 5. And these are both prime numbers. So we could say 2 times 5 times 5 is equal to 25. So then for 100, we just do the exact same method. So we can break this down into 10 times 10. That's something I think of. You could do 2 times 50, 4 times 25, whatever it is. Now I can just think of 2 and 5. Since they're both the same, we can write them like that. And so I know that 2 and 5 are both or all prime factors. And so we could say that 2 times 2 times 5 times 5 is equal to 100. This one up here should have been 50. My mistake. And so you can see the main thing here that I'm trying to denote is that you want to line these up vertically in columns so that you can see which ones are common, because you can't bring down both of them. And so that would be brought down, 5 would be brought down there, 2 would be brought down, this extra 2 would be brought down. And so if we were to do that, we could say 2 times 2 times 5 times 5 would be the LCM, which would be 2 times 2, which is 4. 4 times 5 is 20, times 5 is 100. And so the LCM of 50 and 100 is 100. Awesome. So that brings us to the end of section 2. And so in the next few lessons, we'll start to look at negative numbers and positive numbers, so integers as a whole, rather than just restricting it to whole positive numbers. And so that'll be super interesting and will certainly help with your foundations for algebra. At the end of these whole lectures, we hope that you'll be ready to tackle algebra. You've done bits and pieces of simplifying, very easy stuff. In actual algebra, you'll start looking at things like quadratics and cubics and some of these topics where you'll really have to have a good grasp of all these concepts. And a lot of this isn't necessarily taught commonly where it should be. And so I feel like everyone will find some applicability and some usefulness of this course on pre-algebra. And anyone that's already done algebra would most definitely have some kind of little nuggets of wisdom in here that will help them improve their algebra skills and maybe even go further into calculus. So if you're enjoying these videos, give us a like and subscribe. If you have any feedback or any specific requests, I'm always happy to listen. You're welcome to reach out or comment below. And also we have tutors and tutoring available over at kiered.com.au. We're currently running a promotion for 3 sessions for $150 over the Christmas period. So you're welcome to jump on board with that if you're a new client. And we hope to see you in the next lecture. See ya.